So we'll start with the projection of solids. In that we'll study prisms, pyramids, cylinders and cone. So all these solids can be placed in three different positions. There is one. The first case is solids with its axis perpendicular to one plane and parallel to the other. The second case is when the solids has its axis inclined to one plane and parallel to the other. And the third case, the solids with its axis inclined to both planes. So we'll go for the first one. Okay. Solids with its axis perpendicular to one plane and parallel to the other. In that case, we can go for 2. That is the axis of the solids perpendicular to HP and parallel to VP. The other case, reverse, that is perpendicular to VP and parallel to HP. We'll see how these conditions can be drawn in HP and VP. The projection of the solids when its axis perpendicular to one plane and parallel to the other. So before going to the projection of solids, so I'll start with projection of prisms first, okay, then we'll move on to projection of pyramids, then cylinder and cone. So in the prisms, we'll just see what are the different parts of the prism, because in the problems you're going to have some words of or the nomenclature of these solids, the prisms, okay, so it will be named. So in that case, so this is prism. So it will going to have two end faces. These are called as two end faces. So it can be a triangle, so it will be a polygon actually. Okay, so if it's a triangle, three-sided polygon, it will be called as triangle, right? Okay. So you can have a square, so then it will be called as square prism. If it is a pentagon, it's a pentagonal prism. Then if it is a hexagon, then it can be called as hexagonal prism. So based on the end faces, they're going to name these prisms. So in that case, you're going to have two end faces. One will be below the other. Then you're going to imagine the axis from the center of this polygon to the other end. Okay. So the line joining from this end, if this is the base, if it is resting on HP, one of the end faces will be called as base and the other end face will be the top face. So then line joining from the center of the base to the top end face, an imaginary line at the center will be called as the axis. So then these are called as longer edges, are also called as lateral edges, and these are all called as rectangular surfaces, also called as lateral surfaces. So all lateral surfaces are rectangle, so that's why they call it as rectangular surfaces, whereas all these lateral edges are longer than this, the base edges or the top face edges, okay, all will be same, okay. So then this will be called as shorter edges or base edges, whereas these are called as longer edges. So in all the problems, they're going to refer to these words. Okay, they'll say resting on one of its longer edges, one of its shorter edges, one of its longer edges, the axis is inclined, resting on its base, the top face is nearer to the observer. That way you have to know all the different parts of the prism. So we'll go for the first case where the prisms with its axis perpendicular to one plane and parallel to the other. So I'll take this plane, this drawing this sheet as the horizontal plane, whereas this I'm going to imagine that as a vertical plane. So then I can keep the solid resting on one of its end face. That end face will be called as base. So then if it is resting on its base, we'll observe that, okay, so the axis will be perpendicular to HP and will be parallel to the VP. So it's perpendicular to one plane and parallel to the other, right? Okay. So when it is resting on its base on HP, then axis will be perpendicular. So that's the simple position. Okay. So when it is resting on its base on HP, so the axis will be perpendicular, and also we observe that all these longer edges will be perpendicular, and even this rectangular surface will be perpendicular to HP. The longer edges, rectangular surface, and rectangular surfaces, and the axis all will be perpendicular to HP. And also we notice that the axis is perpendicular to HP and it will be always parallel to VP. So since these longer edges are parallel to the axis, even they will be perpendicular to HP and also all will be parallel to VP. Right? So then if I keep the solid in that first position, that is when the axis is perpendicular to HP and parallel to VP. So then if they ask you to draw the projection of the solids, then I can keep the solid in different positions. So I'm going to get the different view when I'm looking in the front and the top. Okay. See, the view go on changing because when you rotate the solid, the prism. So in that case I have to define exactly the position of this prism with reference to two mutually perpendicular the planes, what we call it as horizontal plane and vertical plane, HP and VP. So then if I keep this prism in this position, I can say that, okay, so the prism is resting on its base on HP such that one of its rectangular surfaces is parallel to VP. Say if I keep in this position, then the view changes, but this is also, I can say that, okay, so it's a prism resting on its base on HP with one of its rectangular faces parallel to VP, but there is a difference in the view. So say rectangular surface parallel to VP, even in this position, rectangular shape, rectangular faces parallel to VP. So you have to define exactly how this is placed, whether in this way or this way, because for both these I can say one of its rectangular surfaces is parallel to VP. So in that case I can fix this position by saying that, okay, a triangular prism which is resting on its base on HP has one of its rectangular surfaces parallel to VP and is nearer to it. And I can say with reference to the observer it is away from the observer. Whereas if I keep in this way, then I can say that a triangular prism resting on its base with some dimensions, they will going to give you the dimension of the prism, saying that a triangular prism having 30 mm base edges and height of 60 mm is resting on its base on HP such that one of its rectangular surface is parallel to VP and is nearer to the observer, whereas this surface is now away from the vertical plane. So completely reverse. That is the condition. So if I say this condition, then I can fix this. So in this position, how exactly the prism looks in the front and the top, that will be the projections of the solids. So in that case I can say this is the position where one of its rectangular surfaces is parallel to VP and nearer to the observer, whereas in this case one of its rectangular surfaces is parallel to VP and is nearer to VP and nearer to it, in that way I can say. I'll go for drawing all these positions of this prism. Okay. If you go for drawing say the different position in this view, okay, I'll go for the triangular position. So the same, any prism, the same condition. Okay, so you can go for keeping any prism in that particular position. If I say draw one of its edge of the polygon, so where you're going to name the solid prism with reference to the end face, which are polygons, okay, as a triangle, so triangular prism. Then ABC is the top end face, whereas A1, B1 and C1 is the base, the other end face. So ABC and this is A1, B1, C1. So both will be overlapping, so that's why. So the, which is in the top, which is visible, I have marked without bracket, whereas this base, which is exactly below this, which is invisible, I have kept that in the bracket. So then I'm going to locate the centroid. Locating the centroid in all the prisms is very easy. Okay, center of the polygon. Just bisect any two sides of the polygon. Okay, so then the intersecting point can bisect any two sides or any two corners, angles. Okay, so then that will give you the axis. Okay, so bisecting and this bisecting. Okay, so then that becomes O and O1. So that's the axis. So because you're going to have the axis, and when you are looking in the front, okay, so there may be some edges which are invisible. In this case, if you take, okay, so I cannot see this edge. I'm looking when I'm looking in the front, okay. So then there will be some visible edges and invisible edges. So you have to differentiate all these edges with a different style of lines. Okay. So then if it is a visible edge, okay, so all visible edges will be marked with a thick continuous line. So all these will be visible edges. So invisible edges will be marked with equally spaced equal length dashed line. It's also called as dotted line. Okay. So this will be used for invisible edges. Okay. So dashed line or dotted line for invisible edges, and all this will be a thick again. Okay. Whereas the axis line will be represented with a big dash and a small dash. A big dash and a small dash. Big and a small. This is called as the axis line. It's also called as chain line. So all chain lines will be used for representing the axis. So if you draw any line like a dotted line, a dashed line, what we call, that will be invisible edges. Whereas if you draw a thick continuous line, okay, so then that will be a visible edge. Okay, this will be the invisible edge. Okay, right? We'll go for now. Draw this. Okay. So now this is the position where I can say that it's a triangular prism of 30 mm base edges and a height of 60 mm, okay, is resting on its base on HP. So, okay. So how? So they say that such that one of its rectangular surfaces is perpendicular to parallel to HP, parallel to BP, and is nearer to it. Okay. So if I project this line, axis and this will coincide. Okay. So then this will be the edge. Okay. So then this is A, B, C with all dashes, and this is A1, B1, C1, O and O1 dash. So then this will be the view for this position. Okay. So when a triangular prism resting on its base and HP such that one of its rectangular surfaces is parallel to BP and nearer to it. Okay. So this is the projection of that solid, this particular position, in this particular position. So if I keep in this way, we'll see how will be the view. Okay. So this is the position where I can say it's a triangular prism of 30 mm base edges and a height of 60 mm, resting on its base again, such that one of its rectangular faces is parallel to BP, similar to that, but this is nearer to it, but this is nearer to the observer. Okay. So then I'll go for drawing this edge. So then it will be this A, B, C, same A1, B1, C1. Then this is the axis O1. So in this position, we'll see how exactly it looks. Okay. So if I project all these points, the vertical plane, that will be the view. So I can get the view. So you might see. So in this case, I need not draw actually this edge completely, because so I can see only these two edges, not this edge. Then I have to draw that edge with a dotted line, right? Okay. So then this will be the dotted line. Okay. So then this will be the dotted line, right? Okay. So then if this is ABC, this will be A1, B1, C1, all will be dashes. Whereas axis will coincide, but will give the preference to the edges. Okay. Dotted line with this axis. Okay. So we'll go for this particular position. We'll see how exactly this can be drawn. Or I'll name this position. Okay. So, or if you want to keep this solid in this particular position. So how exactly you define this position of this solid. So then I can say this, it's a triangular prism of 30 mm base edges and the height of 60 mm is resting on its base on HP such that one of its rectangular surfaces is perpendicular to VP. Right? One of its rectangular faces is perpendicular to VP. So in that case now I can keep this one of its rectangular surfaces perpendicular to this VP. If I imagine a vertical plane here, even I can keep in this way also, making this surface to come in this way. So even here, so I can see that this rectangular surface is perpendicular to VP, either this way or this way. So it's perpendicular to VP. So in that case I have to define how exactly it is placed, whether it's placed in this position or in this position. So then I can say that a prism, a triangular prism of all the dimensions will be given, like having the base edges of 30 mm, the height of 60 mm is resting on its base on HP such that one of its rectangular surface is perpendicular to VP and is towards right. So if I keep in this way, I can say it is towards left. One of its rectangular surface is perpendicular to VP and it's towards left. So in that case, I can go for drawing. I'll go for just drawing only in this particular position. So then they say draw its projections. So then I'll go for drawing that. So go for drawing a edge, complete that polygon. If it's a triangle, go for drawing a triangle. If it is a square, draw a square. If it is a pentagon, construct pentagon. If it is hexagon, construct hexagon. So any solids, the same procedure. So then this is ABC, A1, B1, C1. So they locate the axis. So that will be the axis O1. So O is the top end face and O1 is in the bottom. So invisible. So put it in the bracket. So we'll just project now. So in this case, we can say that each edge will actually represent a rectangular surfaces, because this A1, B1, B is the rectangular surface. So A1, B1, B, because ABC and A1, B1, C1. So A1, B1, C is this line represent actually rectangular surface. So this edge represent rectangular surface. This edge represent one more rectangular surface. And these corners where I have A1, B, B1, C, C1, it represent this longer edges, because all these edges are perpendicular. They look like a point, because this edge is perpendicular to HP. So it is looking like a line. So that becomes the corner of these polygons. So then I'll go for projecting this. So then this will be the view, right? So wherever you can represent the axis, you have to represent. If it is coinciding, give preference to the edges. So here we see that. So the edge is perpendicular. See, this is in the front. I can see the visible edge, so I mark that as a thick line. Behind this, there is an axis. I need not represent that because it overlaps there. So need not represent. So here again, it's a dotted line exactly in front of that. Actually, there's O1, but we'll put that in the bracket because we'll give preference to the edges, right? Whereas in this case, I can represent the axis because see, there is no edge overlapping this. Then I can represent the axis with a chain line. A big dash, a small dash, a big dash, a small dash, a big dash, a small dash, a big, right? So we'll go for marking this A dash, B dash, A dash, top and face, A1, B1, C1, all dashes, front views. So there I can see B, B1 and C, C1, not A1. So I'll put that A1 in the bracket. So now this is the solution for the problem. So what I defined. So otherwise I'll say I can define the problem for this particular view. Something like this. If the view is in this way, I can say a triangular prism of 30 mm base edges and the height of 60 mm is resting on its base on HP. That's why the base is on, that is A1, B1, C1 is on XY line. Base on HP such that one of its rectangular surface is perpendicular to VP and it's towards right. Draw its projections. So then this will be the solution. If surface, one of its rectangular surfaces perpendicular to VP is now towards right. I can draw it towards left, and then I have to define that particular position, right? In the same way, I can have actually the solids kept in VP with its axis in VP. Something like this, okay? So where if you imagine this as VP, okay? So then I can keep the solid something like this, okay? So where the axis will be now perpendicular to VP. So base is in VP and the axis is perpendicular to VP and parallel to HP. Okay? So in that case, I can see actually the view or the end face in the front view, and this axis, no, the length of the axis or the longer edges, it is full length, okay? I can see in the top. So then it will be completely reverse of this what I am looking at. So the polygon is on HP because the axis is perpendicular to HP, and I can see that polygon, the true shape of the polygon on HP. I have to start my view on HP, then I'm going to get this view. Whereas if you have a prisms resting on one of its resting on its base such that, okay, the axis is perpendicular to VP, resting in VP, and axis perpendicular to VP, then I can see that end face in VP. So then I will go for drawing in this way, okay, completely reverse of what I drawn, okay, previously. Then I will go for drawing this. So in that case, now I can keep the solid again, okay. If this is VP, I can keep the solid, something like this. So in different positions, so that again, if I can keep in any position, then the view goes on changing, okay. So in that case, okay, so I can keep something like this. Say, okay, if I keep in this way, I can say that the prism is having its base in VP such that, okay, one of its rectangular surface is parallel to HP and is nearer to the observer. So I can just turn like this, so that this rectangular surface now again parallel to the horizontal plane, but okay, it's nearer to the horizontal plane. Same condition. So again, this it's having its base in VP, but rectangular surface parallel to HP, even in this case and this case. But to define exactly this, I can say this rectangular surface is nearer to the observer, whereas here it's nearer to horizontal plane. Okay. So the same way, okay, I can go for this. So anyway, you're not going to get much of the problems. So something like this. So in that case, I can go for having the first position, having this something like this. Okay. I can rest this on HP, or I can keep it above this HP, so that I can have only having its base in VP above HP, right? Okay, so this is ABC with all dashes, then A1 dash, B1 dash, okay, C1 dash. So that's the base which is lying in VP, O1 dashes. Okay, so then I can say if I say if there is a problem saying that this prism is having its base in VP, then I have to have this base touching this XY line, because when I'm looking at this horizontal plane, so this is nothing but the vertical plane, right? Okay, so horizontal plane, this XY line itself is nothing but the vertical plane. Okay? So anything touching here is nothing but it's touching XY line is nothing but it is touching VP, because this is horizontal plane and this is vertical plane. Always they will be mutually perpendicular to each other. So anything which is touching XY line, so the view, if it is touching XY line, the horizontal plane is nothing but it is touching VP. So in that case, if I have this base touching XY line on the horizontal plane for this rectangle, okay, so which is the front view, if I project that, taking the height of the solid, whatever is given in the problem, so then this will be the view. So this is nothing but A1, this is B1, this is A and B, that's the top rectangular surface what I can see, that's nearer to the observer, right? Okay. Whereas this C1 you cannot, okay, because this is the rectangular surface, you cannot see this edge when you are looking at that. Okay, so because this is exactly behind this, okay, so that's the edge, you cannot see that, you have to pass through the solid to see that. Then that becomes the invisible edge. In that case, I can go for drawing that with a dotted line, right? And this becomes C1 and C, right? The same way you can have one of its rectangular surfaces parallel to HP and nearer to it, that is nearer to HP. So in that case I can go for drawing this in this way. So it's nearer to HP, but having that one of its rectangular surface, right, again parallel to the horizontal plane and nearer to it. In that case, so this will be ABC, A1, B1, C1. So this is vertical plane, so all the should be with dashes, okay. So O dash bracket O1 dash, okay. So then if I project, okay, so it says one of it's having its base in VP, then this will be the base, then this will be A1, B1 and C1. So by knowing the height up to that height, I can take that length, okay. So all these edges, then I can make it dark, okay, the outermost edges. Whereas to check out whether this CC1 is visible or invisible. So in this case it is invisible, whereas in this case it is visible. So visible edges, we know that visible edges should be drawn with thick continuous line, a dark line, okay. So this will be ABC. So CC1 is the topmost edge which is visible. I can reach that, see, that line directly when I am looking from the top, right? Okay. So this is the condition, okay. So in that case, so this is the view. So all this CC1, BB1, AA1. Whereas in this case, so this is AA1, BB1. So this CC1 is a dotted line because I cannot see, right? Okay. The same way I can have one of its rectangular surfaces perpendicular to HP towards right, okay, or towards left. So that way I can go for having even this A1, B1, C1 with its axis O1, O1 with all dashes because all are front views, okay. So then I'll go to project this. So then I'll go for drawing the height by knowing the height, okay. So if the height is given, I will go to take that particular height, then I'll complete the solid, okay. So then this will be ABC, sorry, A1, B1, C1 because that's the base, okay, and this is ABC. So A I can see, so B will be in the bracket, okay. So B can put in the bracket, whereas the axis here again I can, there's no overlapping, then I will represent the axis using this chain line, and this chain line should be a medium thickness. So using H pencil you can go for drawing that O1, right, okay. So now you can differentiate now, okay. So this is a prism resting on its base on HP. That's why there's a true shape of the polygon on HP. And in the front view, so if it is resting on HP, you can see a rectangle, like, okay. So this is your front view. If this is HP and this will be VP, right, okay, XY line resting on the base, okay. So where this is the view, top view, whereas this is the front view. See, top view and this is the front view. The top view I can see in the front all these three edges, so I can make out that, okay. So all the three edges with the dark line, whereas here this is the position, okay. See, triangular prism having one of its rectangular surfaces parallel to VP and is nearer to the observer. So in that case, so when it's resting on HP, so this is the one what you see in the front, okay. This is the one what you see in the top, right, okay. This is the front view. So then 1, 2, so this CC1 you cannot see, so that will be a dotted line. So this is the condition where one of its rectangular surfaces is perpendicular to vertical plane, it's towards right, okay. So in that case, so this will be the top view, whereas in the front view this is the one. The same way now here it's completely reversed, okay. So where I'll say that, okay. So now this is in VP, so if you take this is in VP, now this is the position, okay. So where one of its end faces, so that is the base is in VP, right, okay. So in that position, okay, so how exactly it looks in the top and front. So this is your top view, so this is the one top view, whereas in the front view you can just see that, okay. So this is VP, I'll just turn it for you, okay. So this is VP. If you take this as VP, then this is lying in VP. So one of its rectangular surface is parallel to horizontal plane. If you imagine this is the horizontal plane, okay. So parallel to horizontal plane, and whereas the rectangular face which is parallel to horizontal plane is nearer to the observer. So then this is your top view. So dotted line because you cannot see that, okay. If it is turned like this, VP having its base in VP, then you can see all the edges So all with thick line, okay, whereas in the front you can see a triangle like this, okay, right, okay. So that's the one, okay. So this is the position, okay. So where you're going to have one of its rectangular surfaces perpendicular to HP, okay, and towards right, okay. So having its base in VP. So at the top you can see something like this, okay. So where the axis is it's not coinciding with any of the edges, so I have to represent that, okay. So you can see that this rectangular surface is this A1, A1, B1, BA, A1, B1, BA. So that is perpendicular, that's why it's a line here, okay. So this is the one, okay. So anyway, these are the simple positions you have to understand, okay, before we go for the next position. The solid with its axis inclined to one plane and parallel together. So the next class we'll move on to this solids with its axis inclined to one plane and parallel together. Okay, thank you.